Okay, so this is 2.7 day 2 where we start dealing with an A value, but I wanted to kind of hit real quick and remind you of kind of the steps to how to graph the absolute value. First thing we got to do is identify the vertex. If you remember our general equation here, y equals A times the absolute value of x minus h and plus k. Alright, so the vertex is always the ordered pair, the opposite of h and k. One of the things that I noticed yesterday was that a lot of you messed and forgot to take the opposite of h. It's always, if this number is positive in here, it's going to be negative in your parentheses. If it's negative in here, it's positive in your parentheses. The difference today is going to be now all your a values yesterday were 1. Well, today that's not going to be the case. Today we're going to up the game a little bit and we're going to make a different number. So I've written this example in here. This is an extra example. It says y equals negative 1/3 times the absolute value of x. So first thing I want to do here, identify what are my a, what are my h, and what are my k. Okay, the a value is always the number that's in front of the absolute value, so my a value is negative 1/3. And you'll notice I don't have a number in here for h, okay? I don't have a number with the x inside the absolute value, so what this is showing is there is no h. Well, if there is no h, my h value is 0. And you'll also notice that there's nothing behind the absolute value, which means also that my k value is 0. So my vertex is the ordered pair 0 and 0. So I'm going to put a dot at the ordered pair 0, 0, just like so. Okay, now my a value. My a value, remember, tells me how I find my next point. So my a value tells me from my vertex, I'm going to go down 1 and I'm going to go right 3, just like the slope on a line. So from where my vertex is right here, I'm going to go down 1, and I'm going to go right 1, 2, and 3 dots. So I go down 1, I go right 1, 2, 3, and I'm going to put a dot right there. And then I'm going to go down 1 more, and I'm going to go right 3 more, put another dot. Now, let's see here. I am fairly certain that this one's yellow, since considering yesterday I screwed this one up. And I think I selected the green one and thought it was yellow. I promise you, I'm pretty certain this time that this is yellow. So the yellow line is my axis of symmetry. Okay, that means whatever's on the right side is going to match the left side. So I've got to count here, how far is this dot away from that yellow line. So it's 1, 2, and 3. That means I have to go 1, 2, and 3 and put a dot right here. So I'm going to put a dot over there. And let's see here, 1, 2, and 3 right there. And then the other dot is 6 points away. So I'm going to go 6 points away from that yellow line, just like so. And now I can draw my graph, my line, through like so, and through like so on each side. And I still have the shape of a V. But you'll notice, compared to yesterday, that this graph is much, it looks like I've taken it and opened it up more. Okay, so this is what we call, in this case, what we call compressing. Okay, we're compressing this thing, this graph. Okay, another example that I want to look at that is very similar to problems you're going to see today is the second one. You're not going to need to worry about this third one here. Okay, oh, one other thing about that previous graph too, you'll notice that the a value was negative, so it made my v go down. We're going to talk about transformations here after a little bit, maybe in a different section coming up, and we're going to talk about how to what we mean by transformations. Okay, all right. So in this one here, again, my vertex is the opposite of h, which the opposite of this number right here, so that's going to be negative 4, and the k value is right there, which is negative 3. So that tells me that I'm going to have an h value of -4, a k value of -3, and my a is 2. Okay? Or 2 over 1. You'll see why I go over 1 here in just a second. All right, so I want to plot my vertex first again. So my vertex tells me I'm going to go left 4, and I'm going to go down 3, put a dot right there. Left 4, down 3. So I start at the origin, go left 4 units, go down 3 units, put my first dot. Then my next point is going to be found using my a value. This tells me that I'm going to go up 2, since it's positive, and I'm going to go right 1. Okay, so I go up 2 dots. I go up 2 spaces, and I'm going to go right 1. So I go up 2, right 1. Whoops. Don't want to put it there. Up 2, right 1. We're going to put it there. And I go up 2 more, and I go right 1 more, put it there. And then, again, I'm fairly certain this is yellow, but I guess we're going to find out for sure when you guys watch this. Here is my axis of symmetry. And some people were asking, do I need to draw my axis of symmetry like you do? You don't have to if you don't want to. Sometimes it helps me see a little bit easier how to graph things. Kind of helps me visualize it a little bit better. But that's entirely up to you. You do not have to draw that axis of symmetry if you don't want to. So then I got to go over 1 point from there, put a dot, and I'm 2 points from there, put another dot over there, just like so. And now I can draw my V. So this V is going to look like so. It's going in an upward direction because my a value is positive. And here is the rest of my V. Just like so. Okay, so now you should be able to graph any absolute value equation I give you. Okay, where a is not necessarily 1. You've got an h, sometimes you don't. You got a k, sometimes you don't. But you should always be able to graph absolute values.